So hello and welcome in this video on the regression analysis. Okay, so today's video is on the topic regression analysis, and this is closely related to the correlation. Means when we are having two variables, so let's say x and y be two variables, then the correlation, if you are studying the correlation, then correlation provides the degree and direction of their relationship. Direction means if you are having the positive correlation, this means that they means the variable x and y are moving in the same direction. Means when you are increasing the value of x, then y will also increase, and if you are decreasing the value of x, then y will also decrease. Now the negative correlation means the variables x and y are moving in opposite direction. Okay, so now we are having the movement which is opposite in direction. Means what do we mean by this? So this means that if you are increasing the value of x, then y will decrease. Okay, so if you want to study, or if you want to look at this positive and negative correlation, so if you are in case of positive relation, if you are increasing the value of x, then y will also increase, and if you are decreasing the value of x, then y will also going to reduce or decrease. Now on the other hand, when you are having the negative correlation, then if you are increasing the value of x, then y will moving in opposite direction, means y will going to decrease, and if you are decreasing the value of x, then y is increases. Okay, so y will increase here. So this is we are having as our negative correlation. So correlation, as we discussed, that you will get the degree and direction about their relationship. When you are dealing with two related variables, then you are having this type of information by performing the correlation for these two variables. Now what is the use of regression? So regression comes in play when you are having let's say you are given certain values of x and y. Okay, values are given, certain values are given, but some values are missing. Okay, so some values of y are missing, corresponding to corresponding to some given values of given values of x, and conversely, means you are given some values of y and you have to find out the corresponding values of x. So when we have to do this type of investigation, then it is very much required that we have to draw certain relationship between x and y. So once we are having, so main goal is to derive a relationship between x and y. Once we are having a relationship between x and y, we can easily find out the values of missing values of y for some given values of x, and other way around, means some missing values of x for some given values of x. So in case of linear regression, okay, which is the topic of this video, that we are having this linear regression. So linear regression is simply intended to drive a linear relationship between x and y, means you will have to obtain equations of lines connecting the variables x and y. So because in case of regression, the choice of independent and dependent variable is not fixed, means there is a possibility that x is independent and y is dependent, and there is also a possibility that y is dependent and x is y is independent and x is dependent. So we are having a first situation where y depends on x, and we are having another situation where you are having that x, the variable x, depends on y, means x will be considered as the dependent variable. So for this case, we are having a line which is line known as y on x, corresponding to y on x, means you are assuming that y depends for its values on the variable x, and the equation is y minus y bar is equals to b by x, x minus x bar. So here these y bar, x bar are the mean, so x bar is the mean for the variable x, y bar is the mean for the variable y, and this b by x is the regression coefficient for y on x. Okay, so these are the meaning of these symbols. Now when you are considering that x depends on y for its values, so the equation of line, means the equation corresponding to this, is considered as x on y, and the equation is x minus x bar is equals to bxy y minus y bar. Here x bar and y bar has the same meaning. Okay, so we are having same meaning of x bar and y bar, and this bxy is the regression coefficient regression coefficient for x on y. Okay, so in order to determine these equations of line or lines of regression, we have to find out these four values, means x bar, y bar, byx and bxy. Once we are having these values, we simply put these values here and we will obtain our lines of regression. And we know that x bar, which is you can say that x bar, which is the mean for x, can be obtained by simply finding the expectation of x. Similarly, when you are looking for the value of y bar, so all you need to do is you have to find out the mean for y, which is expectation of the variable y. Now moving towards the next symbol, which is byx in this case, so that is your regression coefficient. Okay, so the regression coefficient is given as r times sigma y over sigma x. Now here this r is the correlation coefficient, okay, between the variables x and y. Sigma x is the standard deviation of the variable x, and sigma y is the standard deviation of y. So you have to find out these three quantities in order to obtain your b by x, or you can say the regression coefficient for y on x. Now we know that r can be obtained by finding the covariance between x and y, and this should be divided by sigma x and sigma y. So where this is the covariance, this is the covariance between x and y, and sigma x and sigma y is same as defined here. So in order to obtain this r, we have the value of covariance of x and y, and further the covariance of x and y can be obtained by using expectation of xy, or you can say the joint expectation of the variable x and y multiplied by minus the multiplication of their individual expectation. So we have to find out the joint expectation so that we can find out this covariance of xy, and we can use this covariance to obtain the value of r. Now further, sigma x can be obtained by using expectation of x square and expectation of x by using this formula, and similarly sigma y can be obtained by using this formula. So here we have to calculate the expectations of x, y, x square and y square, so that we can find out the standard deviation for x and y. So once we are having all these informations, we can easily calculate the regression coefficient, and once we are having regression coefficient and the mean, we can easily obtain the these regression lines here. So now coming back to this second line, which is x on y. So here x bar and y bar are having the same meaning. So we have already discussed here. Now how do we obtain the values of bxy? So bxy can be obtained by r times sigma x over sigma y. So here r, sigma x, sigma y have the same meaning as we discuss here. So we have to find out all the expectations, means the joint expectations and the marginal expectations for x and y, so that we can find out the covariance, the correlation coefficient, which later on can be used to obtain the values of byx and bxy, and we can find out the regression lines. Now again I would like to mention here that certain remarks, or you can say the properties of these regression lines. Okay, so remarks. So to illustrate these or to explain these remarks, let us write the regression lines here again. So y on x have the formula as y minus y bar is equals to b by x, x minus x bar. Similarly, x on y can be written as x minus x bar is equals to bxy, y minus y bar. So now further, if you multiply the product, or sorry, you can multiply the two regression coefficients, so you are having r times sigma y over sigma x, which is the value of b by x, multiplied by r times sigma x over sigma y, which is the value of bxy, and you can see that they will be cancelled out and you will get r square. So this gives us a very important information, which is as we know that r lies between 1 to minus 1. So this implies that r square is always belongs to this interval, means r square cannot be negative here. So it is very much clear that this implies bxy and byx, the product of these two regression coefficients, is always less than equals to 1. Further, this is also greater than equals to 0. So from here you can deduce that this implies that byx and bxy both should be of the same sign. Okay, should be of the same sign, means either they both are negative or they both are positive, because if they are having opposite sign, then you can see that this product will become negative, and which is not in the given boundaries. Now next is if we consider the point x bar and y bar, and let us call this equation 1 and 2. So this is a point on the plane where the values of x, the value of x is x bar and the value of y is y bar, and putting these values in equation 1 and 2. So if you are putting these values in equation 1 and 2, so you can easily check that you will get 0 is equals to 0. Okay, because if, let us explain this. So we are having this line which is for x on y. Okay, so now if you are putting x in place of x, you are putting x bar. So this x bar is here, and here you are having y bar minus y bar. So this will give you the required condition, means 0 is equals to 0, because this is this will become 0, and here this y bar minus y bar is equals to 0. So when you are multiplying this bxy with 0, so you will get 0. So this shows that two regression lines will passes through or will pass through the point x bar comma y bar. So these lines will always pass through these this point which has the coordinates x bar comma y bar. Now keeping this in mind, a very common problem is that, so let us consider here an example. So suppose you are given two lines, let's say 2x plus 5y plus 19 is equals to 0, and something 3x plus 9y plus 15 is equals to 0. So we are having this pair of straight line. Now we have to check whether the above lines are regression lines. Okay, so we have to check whether these are regression lines, and we have to calculate the mean of x and y, and the third thing is the coefficient of correlation, means the value of r. And before we proceed towards this, let us begin with this first part. So we have to check whether they are regression lines or not. So for regression lines, we will consider that the given lines are regression lines. So let us begin with the solutions, and in this solution we are considering that the given lines are regression lines. Okay, so if they are regression lines, then one of these line is y on x and another one is x on y. So let us consider this line as x on y, and this second line as y on x. Okay, now before we proceed towards this important problem, let us discuss another important concept which I forgot to mention above, and that is, if you are having this line which is y on x, so this is the equation for this line. So this is y on x. Now in coordinate geometry we are having this type of equation of line. So this is the equation of line, or you can say that this is slope intercept form of the line. So you can convert this equation like y minus y bar is equals to byx into x minus byx into x bar. Now if you are transferring this towards the right hand side, so you will get y is equals to byx into x minus byx into x bar plus y bar, or you can say that this is byx into x minus byx into x bar minus y bar. Now if you compare this equation with this, okay, so we are comparing this, so or you can mark this as equation A and this as equation B. So from A and B we get, so if you are comparing, so you can see that here the coefficient of x is the slope of this line, and here this coefficient of x is the regression coefficient for y on x. So we get m is equals to b by x. And similarly for the line x on y, means using this line, we can obtain that the regression coefficient bxy will be the slope of this line. Okay, so the regression coefficient or you can say the regression coefficients provide the slope. Okay, so keeping this information in your mind, it is very important. Now coming back to our problem, so we are given here two lines, and we have to check first of all that these lines are regression lines or not. So let us begin with the solution, and we are assuming that, in fact we have already done here. Okay, so we are assuming that, or you can say that given that two lines, okay, so we are given these two lines, and not basically we are not considering this, that this is given. Basically we have to test, so it will be good if we mention that let the two lines, let the two lines are regression lines. Okay, so if these two are regression lines, then one of the line is x on y and another one is y on x. So we already assumed that. Here we can see that we are, yes, so we are assuming that our first line is x on y and our second line is y on x. So our first line is 2x plus 5y plus 19. Okay, so this is our first line, and our second line is 3x plus 9y plus 15. Okay, so 3x plus 9y plus 15 is equals to 0. So we are considering here that this is your x on y and this is your y on x. So we convert this x on y line in the form y is equals to mx plus c. And how can we do that? By simply rearranging the terms. So because we are considering this x on y, sorry, this is not y on, so for the first line, which we are considering here as x on y, so we have to convert this line into this form. Okay, so here x is equals to my plus c. So we are just transferring these two terms towards the right. So from here we will obtain 2x is equals to minus 5y minus 19, which further gives you x is equals to minus 5 by 2y minus 19 by 2. So this gives you the slope of this line on comparing with this. So we are comparing these two equations, right? So we are obtaining here the value of m as minus 5 by 2. Now we have considered that this line is x on y, so this will be the value of your bxy. Now from the second line we are having y on x. So first of all we will simplify this line, means you can take this 3 outside. So you will have x plus 3y plus 5 is equals to 0. Now because we are considering this line as y on x, so this will be 3y and we are transferring x and 5 towards the right hand side. So this gives you x, this gives us the value of x. So basically we are considering this y on x. Okay, that's fine. So we are having y is equals to minus x by 3 minus 5 by 3. So from here the slope of this line is minus 1 by 3. Okay, so this will be the value of your second regression coefficient, which is b by x here. So we are having bxy as minus 5 by 2, and the second one is byx as minus 1 by 3. Now next what we will do, we will just perform the multiplication. So when we multiply bxy and b by x, so this will be minus 5 by 2 multiplied by minus 1 by 3. So this is coming out 5 by 6, which is less than 1. So this means that this implies that given lines are regression lines. Okay, given lines are regression lines, and so we have to find out if these are regression lines. Then we have to calculate certain things, and that is, we have to find out the mean so we have to find out the mean of x and y here, and we have to find the coefficient of correlation. So as we discussed in our remark number 1, that the lines passes through the point x bar comma y bar. So coming to the second part, we know that x bar comma y bar is the point from which both lines both lines will pass through. Okay, so what we will do, we just need to put these values here. So means in place of x bar we have x, in place of x we will put x bar and y bar. So what we are doing, we are just replacing x bar in place of x and y bar in place of y. So we are substituting x by x bar, y and y bar. So this gives us the equation of two regression lines, which are 2x plus 5y plus 19 as 2x bar plus 5y bar plus 19 is equals to 0, and the second line is 3x plus 9y plus 15, so which is 3x bar plus 9y bar plus 15 is equals to 0. So this is the situation where we are having two equations of line, in fact two linear equation involving two unknowns. So we can solve these equations and we will get the value of x. So we use the simple method here. So first we will eliminate x bar. So we multiply equation 1 by 3 and equation 2 by 2. So this gives us 6x bar plus 15 y bar plus 57 is equals to 0, and here we are having 6x bar plus 18 y bar plus 30 is equals to 0. So when we subtract, so x bar will be eliminated, and here we are having minus 3 bar, and this will give us plus 27 is equals to 0. So this means minus 3 bar y bar is equals to minus 27, and this gives us y bar is equals to 9. So this is our value of y bar, and we are putting, if we put this y bar in this any of this equation, so we are putting the value of y bar here. So we will get 2x bar plus 5 y bar, which is 9, plus 19 is equals to 0. So this gives us 2x bar plus 45 plus 19 is equals to 0, and will just subsequently gives us 2x bar plus 64 is equals to 0, and from here we will obtain 2x bar as minus 64, and which finally gives you the value of x bar as minus 32. So this is how we can obtain the mean. So mean for x variable is minus 32, or you can also say that this is the expectation of x. And similarly we are having y bar which is 9, and you can also call it expectation of y. Okay, so this is expectation of y. Now coming to the last part, which is the calculation. Okay, so here we have to calculate, or you can say the calculation of R, the correlation coefficient. So we know that, okay, we know that bxy multiplied by byx will always give us the value of r square. So here we already obtained the regression coefficients. Okay, So you can use these regression coefficients. So this is our byx, and this is our bxy. Okay, so this is our bxy, this is our byx. Okay, so our bxy is, we know that bxy and byx is equals to r square. So here we will put the values, and if you are putting the values, so our bxy is coming out minus 5 by 2. So this is minus 5 by 2, and byx is minus 1 by 3. So this is coming out 5 by 6, which is the value of r square. So this gives us the value of r as plus minus root 5 upon 6. Now here we are having a remark that the sign, here we are having two sign or two values of r, which are out of which one is positive and the second one is negative. Now remark is that the sign of correlation coefficient will be same as the sign of regression coefficients. Okay, so here we know that in this given problem our regression coefficients are negative. Here both bxy and byx are negative. So we will consider our r as negative. So the value of r is negative root of 5 by 6. So this is how we can deal with the problems where we are given the equations of line, and we have to check whether the given lines are regression lines or not. So here we have to make a remark that if byx and bxy is belongs to this range, we normally have the lines as regression lines. Okay, whenever we this product is not in this given limits, so we cannot say that the given lines are regression lines. Now sometimes we are given one of this quantity, means either you are given the variance of x, or you are given standard deviation of x, or variance of y, or you can say the sigma y. And so one of the quantity is given here, and we have to obtain the other value. Means if you are given the variance of x and you are asked for sigma y, or you can say that you are given sigma y and you have to find out the sigma x. So how do we do that? So let us consider that. So we are again continue with the same problem. So suppose we are given that variance of x is 4, then find the standard deviation of y. So here we will make use of any of the regression coefficients. So let's say we are using bxy. So bxy, the formula of bxy is r times sigma x over sigma y. Here you can see that we have already obtained the value of r, which is negative root 5 by 6. multiplied by sigma x. So sigma x is given here because you are given with the variance. So from here we know that sigma x is equals to the positive of variance of x. So this is coming out 2. So sigma x is 2, and we have to divide this by sigma y because we are not having the value of this sigma y, and the value of bxy is here you can see that bxy is minus 5 by 2. So this is equals to minus 5 by 2. So from here you can cancel out these negative signs, means these negative signs will balance each other, and from here you will obtain that root 5 by 6 is equals to 5 times sigma y, or you can say the 5 by 4 sigma y. Okay, so from here we will obtain your sigma y as 5 by 6 multiplied by 4 by 5, whatever value we are having here. So that is the value of R, or the correlation coefficient. So this is how we can handle the problems where we are given the regression lines or simply lines, and we have to check whether the given lines are regression lines or not. So this is how we can deal with the problems. In our next video we will having some discussion on the calculation of regression coefficients and how do we obtain the regression lines once we are provided with the probability distribution or the probability distribution for a random variable. So that's all.